Consider the box plot below. So here we have a box plot, and this question is all about understanding what a box plot is really saying, what it really means. So when they give us a box plot, let me just lay out some ideas first off for you. Basically, it's breaking all the data values into 4 quarters. This is the first quarter, second quarter, from here to here. Here to here is the first quarter. The third quarter is from here to here. And the fourth quarter is from there to there, so from 20 to 38. So it's breaking the data into 4 quarters, like a football game or a basketball game is broken into 4 quarters. So there's a whole bunch of data values which we're not seeing. And the lowest data value is 3, the highest is 38. That means 1/4 of all the data values are between 3 and 8. I don't know what they are. They're not showing. There's some list of numbers. And then there's a whole bunch of numbers between 8 and 10. Maybe a bunch of 8s and 9s and 10s. 1/4 of all the numbers. And the 1/4 of all the next quarter, the third quarter, the next 1/4 of all the numbers are between 10 and 20. And the top 1/4 of all the numbers are between 20 and 38. So there's a whole big list of data. So for example, maybe let me just do it for instance. Maybe there's 3, 4, 5, 6, and 8. Maybe there's 5 numbers between 3 and 8. That'd be the first quarter. And then there's 5 numbers between 8 and 10. So that would be like, let's just say, I don't know, let's just say 5 9s. Right? That'd be 5 numbers between 9 and 10. Between 8 and 10. That'd be the second quarter. And this is the first quarter of all these. Then there's a bunch of values between 10 and 20. Maybe make 11, 12, 15, 17, 19. There's 5 numbers, maybe. I don't know how many numbers there are. They're not telling me the total number of numbers. And then there's 1/4 of all the numbers between 20 and 28, maybe 20 and 38. Like 21, 27, 29, 34, and 37, maybe. Or let's go all the way to 38 there, I guess. So 38. So there we go. So I'm just saying, for instance, this is a possibility. Maybe there's 5 data values in each of those sections. I don't know how many data, but maybe there's 500 data values in each of those sections. All I know is 1/4 of all the numbers between 3 and 8, 1/4 of all the numbers between 8 and 10, 1/4 of all the numbers between 11 and 19, or 10 and 20, and 1/4 of all the numbers between 20 and 38. That's what I know. A box plot breaks the data into 4 even sections. Okay, now what's their first question here? What quarter has the smallest spread of data? If you can read that there. What quarter has the smallest spread of data? So what do they mean by that small? Well, the small spread is this second quarter right here, right? It only goes from 8 to 10. That's a very small spread. And what is that spread? Well, it goes from 8 to 10, so it's 10 minus 8. It's only a spread of 2. What quarter has the largest spread? Well, that looks like it's the fourth quarter, right? From here to here, this is the largest spread. So the fourth quarter. What is that spread? 38 minus 20, that spreads 18. And find the interquartile range. The IQR, that basically means Q3 minus Q1, interquartile. So from Q3 minus Q1, how far from 8 to 20? That's the width of the box, in other words. The IQR, the interquartile range, is the width of the box. See how that box plot has a box and then it has 2 what they call whiskers that go off to the right and the left. It's called a box and whiskers diagram. So the box goes from the first quartile, the end of the first quarter, to the end of the third quarter. It's called the inner quartile range. So that's 20, goes from 8 to 20, right? So that'd be 20 minus 8, 12. The inner quartile range is 12. And next, which interval has the most data in it? So that means the most data values. Remember, every quarter has the same amount. I said maybe there's 5 data values in each quarter. I don't know, I'm just guessing. Maybe there's 500. But the point is, every quarter has the same amount of data values, whatever that may be. They're not telling us. So now, how do we answer this question? Well, let's see, 10 to 20. From 10 to 20 goes from here to there. So that's just 1 quarter exactly. That's 1 quarter. What's 20 to 38? 20 to 38, that's another quarter. That's the upper quarter. That's 1 quarter of data values. 3 to 10. From 3 to 10, that includes 2 quarters, right? The bottom quarter and the next quarter. That's 2 quarters of data values. What about 12 to 36? 12 to 36. 12 is a little past here. 36 is a little here. That's almost 2 full quarters, just under 2 full quarters, isn't it? Because it starts after halfway and ends before the end. So it's that one, this one here is just under 2 quarters. So this one here has to have the most data. Why? Because it's 2 full quarters of data. From 3 to 10, right? From 3 to 8, however many values are there, 8 to 10, there's a whole bunch of values there. That's 2 full quarters of data. That's going to have the most data. What value could represent the 53rd percentile? Now, 53% of the way along. That's what a percentile means. It means if you order the data values, right, from bottom to top, you say this is the 0 percentile, this is the 100 percentile, this is like 50, then 53 is just past halfway. So which number, which data value could be just past halfway? Well, remember, halfway has to be right here. Because, I only need to erase this thing. It's getting too colored on. So right here, that's halfway, right? Why is that halfway? Because remember, this is the first quarter, second quarter, third quarter, fourth quarter. So even though it doesn't spatially seem to be halfway, it must be half the data values must end right there, because 1 quarter of all the data values are here, the next quarter here, so that's half the data values are between 3 and 10. So that's halfway, right? So if a data value is at the 53rd percentile, if it's 53% of the way along, it's got to be just a little bigger than 10, doesn't it? A little bigger than 10. So it's got to be the 11. It can't be those other numbers, right? If it's the 53rd percentile, it's just past halfway. And halfway, the whole trick is, do you realize halfway is 10, even though it doesn't spatially look like halfway? That's what the box diagram, the box plot, is telling you. It's breaking the data into the first 1/4 of all values, the first quarter, the second quarter, the third quarter from here to here, and the fourth quarter from there to there. This is the second quarter, and this is the first quarter, right? So this is halfway, because 2/4 of the data, 1/2 of all the data values are between 3 and 10. Like here, see how half of all the data values from 3 to, if I made this a 10, let's say from 3 to 10, half the data values go from 3 to 10, the other half go from 10 on up to 38. So if we're looking for the 53rd percentile, we're looking to go just past halfway, 53%. Through the list of data values, just past halfway. Well, halfway is like the number 10, so just past 10, that'd be like 11. That's a possible answer. No way it could be 30 or these other ones, no way. So there it is. There's the understanding of what a box plot